In this sequence of videos, we're going to discuss trigonometric identities. Now, an identity, notice no trigonometric adjective here, is an equation which is true for all x values except maybe a couple. So for example, x squared over x. This is the same thing as x except for x equals 0. So except for x equals 0. X squared over x equals x, I would say that statement is an identity. Also, sine squared x is 1 minus cosine squared x. This is true because the Pythagorean identity says sine squared x plus cosine squared x is 1 for all x. Now, contrast that with an equation, which might look like something like solve x squared minus 1 equals 0. There's only a couple x's for which x squared minus 1 is equal to 0, and I would call this an equation instead of an identity. What we'll be doing in this section is we'll be using identities that we know and algebra techniques to prove that other trigonometric identities are true. Before we do some example problems, let's go ahead and review the trigonometric identities that we know. Probably the most common that we'll use are the reciprocal identities and the Pythagorean identities. So these have been used previously, so I won't go over each of them and why each of them is true. But you will need to know these in order to do the problems that we will work. We'll also occasionally need to use the so-called even-odd identities, which says that cosine of minus t is cosine t. In other words, cosine of t is an even function. Sine of minus t is minus sine t. In other words, sine of t is an odd function. And tangent of t is also an odd function. Let's briefly discuss why these are true. So let's imagine that we travel a distance of t on the unit circle. So throughout these discussions, I'll be using a unit circle interpretation of the trigonometric identities. So if we travel a distance t, and then we envision traveling a distance of minus t as well, so we walk the same length, but instead of going counterclockwise, we go clockwise, then where do we end up? Well, we end up at the same x-coordinate. So if we let a comma b be our terminal point for t, then where do we end up if we travel a distance of minus t? Well, we end up at the same x-coordinate, so a, but the y-coordinate is going to be negative. It's going to be the same magnitude, that is, you travel the same, it is just as far away from the origin, it's just instead of going upwards, you went downwards. Now remember our definition of sine and cosine. So sine of t is the y-coordinate, b, and so sine of minus t is going to be negative b, and we see that, well, sine of t is going to, that sine of minus t, that's just the negative of sine of t, and that's exactly what's written here. The x-coordinates are equal, so cosine of minus t is going to be cosine of t, and then from there you can figure out that tangent of minus t is minus tangent of t because, well, we can use the reciprocal identities. This would be sine of minus t over cosine of minus t. And, well, we know that sine of minus t is negative sine t, so this is minus sine t divided by cosine of minus t is just cosine of t from this identity up here. And, well, now we have negative sine t over cosine t. That's negative tan t. Okay, so these are the even-odd identities, and to be candid, they're used less frequently, but they are still used. Okay, so now that we've reviewed our identities that will be useful, the reciprocal identities, the Pythagorean identities and the even odd identities, let's go ahead and talk about a type of problem that you might come across. So what we'll do is we're going to show that tan theta plus cotan theta is secant theta times cosecant theta. Now, before we start, there's not some sort of step-by-step guide that will that you can follow to solve every type of these problems. Instead, what you'll have are guidelines. I like to think of these problems as I have a toolbox, and there are various types of tools in my toolbox that I can use. One may work, one may not. When one tool doesn't work, try a different one. Sometimes you'll do problems where multiple tools will do the job. So before I go ahead and do this problem, I'd like to go ahead and go over my toolbox of the most commonly used tools. So your toolbox is going to be divided up into two categories here: trigonometric identities and algebra. These types of problems are usually pretty algebra intensive. So if you are a little shaky on any of these algebra techniques here, then you may want to review in your algebra textbook, because we will be doing a lot of algebra. Okay, so obviously the trigonometric identities are going to be useful for us, especially these reciprocal identities. It's often very useful specifically, all of them are useful, but it's often very useful to write tan t and cotan t in terms of sine and cosine. So that will frequently happen, as you'll see in these examples. Now, the algebra skills that typically come up are getting common denominators, factoring, canceling common factors, dividing fractions, factoring differences of squares, so a squared minus b squared is a minus b times a plus b, and foiling. Let's go back to our example here, and let's see how a problem like this might go. Now, what you're going to have to do to show that these two things are equal is you're going to have to start with one of the sides. Let's say we start with the left-hand side, LHS. You'll have to do some algebra / trig work, and you'll be done with this problem when you arrive at the right-hand side. Of course, you could start with the right-hand side and get to the left-hand side. And sometimes even what we do is we start with the left-hand side, we work, we get to some middle point, and then we look at the right-hand side and get to that same point. So which one should I do for this problem? And for other problems, how do I determine which side to start with? Well, there's no right answer for this. You know, on some problems you're going to be able to start with either side. For some problems, it's going to be much easier to start with a certain side. In general, what I look for is what side can I do the most work with? What side sort of lends itself to change more? And what I mean by that is, let me take a look first at the right-hand side. Secant theta, cosecant theta. So what I could do is I could apply the reciprocal identities to this. So right-hand side equals this secant theta, cosecant theta, and that, I guess, would be 1 over cosine theta times 1 over sine theta. But now I look at this and don't really see where I can go with this. I don't see anything in my toolbox here that I can really do to make this change into this left-hand side. And so I think I'll go ahead and start with the left-hand side. Now, as you're doing these problems, there's no shame in saying, in starting with a side, doing some work, and then saying, I don't really see how this is going to work out, and then starting over with the other side. So let's see, so tan theta plus cotan theta. So I'm going to use the tool in my toolbox of rewriting tan theta and cotan theta as sine theta over cosine theta and cosine theta over sine theta. And as you're doing these problems, you should state what identity you are using here at each step. So this was also reciprocal identity. I'm definitely going to need some more room. Okay, so now I ask myself, what can I do with this? Notice that question, what can I do with this? I'm not asking myself, what is the correct step? I'm asking myself, what identities or algebraic techniques can I do to this? And it may work and it may not. If it doesn't work, I'll come back to it and try something different. Now I'm adding fractions here, so I think what I'll do is I'll go ahead and get a common denominator. So if you multiply this by cosine theta over cosine theta, and this by sine theta over sine theta, that will get us a common denominator. And so this would be sine squared theta plus cosine squared theta, all divided by sine theta cosine theta. And so this was common denominator. And now, well, cosine squared theta plus sine squared theta, that's 1. So this is 1 divided by sine theta cosine theta. So Pythagorean identity. And then finally, I can use my reciprocal identities again. This is 1 over sine theta times 1 over cosine theta. There's nothing really to write here. You could put algebra if you want. But then finally, 1 over sine theta times 1 over cosine theta, that's cosecant theta secant theta. So reciprocal identities, and well, that's the right hand side. That's what I wanted to show. I wanted to show that tan theta plus cotan theta was secant theta cosecant theta. And that's it.